Hey, this is Leach with Simpson Math, and in this video, we're going to be applying the use of Pascal's triangle to the binomial expansion. So let's take a look at this example. This is to write the binomial expansion for x plus 2 quantity to the fifth. So before we do that, I don't want to deal with the 2 just yet. Let's just do with x plus 5. I'm sorry, x plus y to the fifth. Actually, rewind one sec. Let's actually do x plus y squared, just to make sure we're clear about what we're doing. So if I was tasked to expand this binomial, what that really means, if you know about exponents and squaring things, so if I'm squaring something, it means to multiply it by itself. So this really is x plus y times x plus y. In my college algebra classes, this is kind of a big deal because I have a lot of students who want to distribute the square across addition, which is a big no-no. That is not allowed. They end up with x squared plus y squared, which is not right because we're missing the middle term. So let's distribute this, which for my contemporary students are like, oh my gosh, we're doing distribution. We are, but we're not. So with the Pascal's triangle, we're going to be able to avoid doing a whole bunch of complicated distribution, but I'm going to make sure you're clear about what it is that we're doing. So I'm going to show you this. If you're a little fuzzy about distribution, don't stress. We're not doing it pretty much after this. So when I distribute things, I like to, especially when it's something like this, which classically, traditionally, we might refer to this as FOIL. I have these two things that need to distribute in this. I'm just going to focus on the first term. So I'm going to block out that plus y, and I would distribute this x to this x, and then into the y. So I'm going to do x times x, and then x times y, and add them together. So we get I'm going to do this first x. I'm going to kind of highlight this x in orange. So we end up with x squared, which is x times x, plus x times y. Now I'm going to cover up this x, and now I'm going to distribute this y into that second binomial. So I'm going to have y times x, which we will write as xy, and then y times y. I'm going to color this in that teal. So we're going to have plus xy. I meant to hit undo, there we go, plus xy, and then plus y squared. Then we can combine like terms, and we end up with x squared doesn't have a friend, but I have two xy terms, and so I have two xy terms. So we have a coefficient of 2. Coefficient is the number in front of the variable, plus y squared. So the binomial expansion says, instead of having to do all that multiplication work, instead, I can just start with x plus y squared, and then I can look at the coefficients on the second row. Remember, this is row 0, row 1, row 2. So I can be taking a look at this second row, and the coefficients I see, the numbers I see are a 1, a 2, and a 1. So those are going to be my coefficients over here. Notice, what is the coefficient in front of this x squared? Well, we don't see anything, but it's an understood 1. What's the coefficient here? We have a 2. And again, I don't see anything, but there's an understood 1. So we have that 1, 2, 1. And so what we can do is, I'm going to write my x's in green and my y's in purple. So what we do is we take the first term, I'm going to start with it, I'm going to not worry about the coefficients just yet. So I'm going to write my first term and give me my biggest exponent, so x squared. And then in the next term, I'm going to write that that variable again, but going down 1. So I'm going to go from 2 down to 1. When we have exponents of 1, we don't need to write them, so I'm just going to leave that alone. And then my last one, I would have it would be an x to the 0, but an x to the 0, any non-zero raised to the 0 power is just 1. So 1 and 1 times whatever is that 1. So I'm actually going to not need to write that as well. All right, then for the y's, what we'll do is starting at the first term here, we can write this as a y to the 0. Well, again, any non-zero raised to the 0 power is 1, so generically speaking, y to the 0 is going to be 1. So I don't need to write it in that 1 times x squared is just x squared. Then we move up, and there's our now for the y's, we go up by 1, so from 0 up to 1, and then now up to 2. So we kind of write our exponents in this descending order, ascending order, descending for the x's, ascending for the y's, or descending for the first one, ascending for the second one. Then we can put in our coefficients. And so the coefficients that we see are the 1, 2, 1. And then we can be mindful of our signs. Since this is a plus in the middle, then we're able to add them both. All right, so let's take a look at the one that's on the board above me, the screen above me. And we're going to do x plus 2, all that to the 5th. All right, so let's color the x in green again, and let's make the x be 2. So we're going to do a similar process. Eventually, we'll be using the 5th row of the Pascal's triangle. So 3, 4, 5. I don't really need to number them because it's whatever we're going to see in the second row, the second kind of diagonal column, second diagonal. So notice how that's 0, and then 1, 2, 3, 4, 5, 6, 7, so forth. So I don't really need to number them. But this row right here, the 5th row, 1, 5, 10, 10, 5, 1, are going to be the coefficients of my binomial. So if I have an x of 2, I have an x plus 2, it's raised to the 5th. I'm going to start with x to the 5th. And then I'm going to just, the pattern that is nice with this binomial expansion is that we can write this as x to the 5th, skip a bit of space, do x to the 4th, x cubed, x squared. This would be an x to the 1st, and then an understood, we're not going to write it, but an x to the 0. I'm just drawing an arrow there just to save my place, but I'll eventually discard that. All right, then we're going to do a similar thing with the 2's. So we're going to end up with I'm going to start on the far, we can start on the far right side this time and just label this as 2 to the 5th. And then this is going to be, and then we're going to have a 2 to the 4th, and then a 2 cubed, and then a 2 squared, and then a 2 to the 1st, and then there's an understood 2 to the 0 here. Well, 2 to the 0 is 1, so this is just a times 1, so that's where we're not going to be needing it. Similarly, this x to the 0 should just represent 1, so we're not going to be needing it. Lastly, we need to go through and add our signs. Typically, when we're doing the binomial expansion, this first term will be positive, usually, and the second term might be positive or negative. And then we'll need to keep track of our signs. I kind of I think our next example should be negative, so we'll have to see how that works there. But we can kind of associate the negative with this. But since it's positive, then we're just going to have an addition sign everywhere in between everything. If we're looking at the answer above my head, I see this is I see this is a 10 to the it should be 10 times x to the 4th, but it just have a 2 to the 1st, and this should be 40, but this is just 2 squared. It's because I need the binomial coefficients. So I still need my 1, 5, 10, 10, 5, and 1. And notice I have my 6 terms, 1, 2, 3, 4, 5, 6. And these 6 values are going to slot in as the coefficients in front of all of those. Let's write these in orange. So there's my 1, there's my 5. Kind of ran out of room a little bit. Let me adjust this. Boop. Then 10, then 10. Then 5, and then an understood 1 that's not going to do anything. All right, I'm going to switch to, no, I'm going to finish this up. Then let's simplify. So 1 times x to the 5th, we don't need that 1, so it's just 1x to the 5th. You could, if you wanted to, kind of rearrange this. Let's do that. So I have my 5, and then 2 to the 1st is 2, so let's put that in front, and then the x to the 4th. Let's go ahead and, I might skip an extra line and let's go ahead and simplify that while it's on our brain. I know that 5 times 2 is going to be 10, so we're going to get 10 times x to the 4th. All right, for this next one, I'm going to take my 10, rearrange it, and simplify 2 squared to be 4, and then write my x cubed. So what I'm doing is I'm just documenting my 10, 2 2 squared is 4. And so that way I can then multiply those together. Just kind of a little bit of rearranging. If you're a little bit sharper with math skills and this 10 and this 2 squared, you can go, oh, that's going to be 40. Then power to you. Do that. So 10 times 4 is going to be 40. X cubed. All right. Then again, let's rearrange this. I'm going to have my 10. I'm putting in my parentheses around 10, just so that way it's clear that that's 10 times 2 cubed, which is 8, and not 108. And so this is how I end up with 80 x squared. I'm going to kind of just do a little bit of a return because I'm out of room. Plus 5 times 2 to the 4th. 2 to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. Times x to the 1st. 5 times 16 is also 80, so we have 80x. And then we end up with then just 5 squared, which is 32. I misspoke. I said that the wrong way. 2 to the 5th. 2 times 2 times 2 times 2 times 2. That is 32. And so that's how we end up with what we see above me. 5x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. All right, let's take a look at the next question. I'm going to spam this until I get a, do we get a negative? Or I might have gotten rid of all the negatives. Oh, well, no negatives to worry about. I think I intentionally didn't pick any negatives. All right, so this one is thankfully also positive, so we don't have to mess with any sign issues here. And this one is to the 4th power. So what we're going to be doing, this is, I'm going to write it a little bit bigger in case you can't see it well. So this is, we're going to get 5x plus 2 to the 4th. So this is very similar to what we just did, but if you look at every question that I kind of cycle through, because I have a button, oh, you weren't seeing it, I was pressing this, I have a button that I can just spam a similar question. I was just looking at all the options that could pop up, or several of the options that could pop up. So what's different about this is we have a coefficient in front of the x. So we have that one extra little layer to it, but nothing about the process changes. I'm going to go ahead and go to my Pascal's triangle and look at the 4th row. I see it's 1, 4, 6, 4, 1. Let me go ahead and write that down so I don't lose that. So our binomial coefficients is going to be 1, 4, 6, 4, 1. So now that I know that, I'm kind of done with the Pascal's triangle. That's all the Pascal's triangle does. I'm going to go ahead and label my 5x as green and my 2 as purple. And so we have, this is an x to the 4th. Let's move the scooches way over to the left. X to the 4th. So my first term is going to start with a 4th, then it's a 3rd, then it's a square, then it's a 1, and then it's a 0. So this first term is going to be a 5x to the 4th. Skip a bit of space. Then it's going to be a 5x cubed. Skip a bit of space. 5x squared. Skip a bit. 5x to the 1st, which that first isn't really needed, but let's go ahead and write it. And then I'm going to leave a space. I'll erase this in a second for 5x to the 0. 5x to the 0 should be 1 for any valid x's. All right. So now I'm going to do the 2. So I'm going to have a 2 to the 4th. Scooch over to the left. 2 to the 3rd. Scooch over to the left. 2 squared. Scooch over to the left. 2 to the 1st. And then this would be a 2 to the 0. I did start putting parentheses around my 2's. If you come across a negative one, that's where you would, a subtraction, we're going to want to put that subtraction kind of inside that number, and that's how we can do with the negatives that way. Because like a negative 2 squared would be a positive, but a negative 2 cubed would be a negative. So 2 to the 0, that's 1, so I don't need that anymore. And then lastly, we need our binomial coefficients and then the signs. So this is going to be a 1, this is a 4, this is a 6, this is a 4, this is a 1, and then let's put in our addition signs. I can kind of scooch this over, put in our addition sign, addition sign, addition sign. All right, so that's like the hard part, or that is applying the binomial expansion. Now we just need to clean it up and simplify. I'm going to keep my colors going here just so that way we can see. All I'm going to do is just rearrange. And my 5x to the fourth, we can distribute exponents across multiplication. You heard me say earlier how some students will try to distribute the fourth across addition. That is a no-no. So when I think about exponent rules here a little bit, or when I think of addition, multiplication, exponents, they're all related. To me, I think about they're like floors of a house. So I have addition, where you're just adding things up. That is the ground level of a house. If I have repeated addition, so I'm adding the same thing over and over and over, so 3 plus 3 plus 3 plus 3 plus 3 plus 3, that is a version of, that is actually multiplication. So multiplication is repeated addition. So the ground level of the house is addition. The second level of the house is multiplication. We can distribute multiplication over addition. And that's what we were doing when we were talking about foiling earlier. I was distributing this x into the xy. You can distribute multiplication. This is x times x plus y. So you can distribute multiplication over addition because it's one level down, one level down. So repeated addition is multiplication, and I can distribute multiplication over its counterpart, its repeated version down below. If I have multiplication and I repeat this 3 times 3 times 3 times 3 times 3, those are exponents. Repeated multiplication are exponents. So I have three levels of a house. Ground level, I have addition. Second level, I have multiplication. Third level, I have exponents. You can distribute one level down. You can distribute across something one level down. So I can distribute exponents across multiplication, but I cannot distribute exponents 2 levels down across addition. That is a big no-no. So multiplication across addition, yep. Exponents across multiplication, yep. But not exponents 2 levels down across addition. So all that to say is that what's happening here, this 5x to the fourth, this is the same thing as saying times 5 to the fourth times x to the fourth. I can distribute that 4. And I'm putting air quotes there because a lot of math people don't like me using the term that we're distributing the exponents over multiplication, but we are. But I'm putting air quotes there because it makes the math people happy. So I'm able to rewrite 5x to the fourth as 5 to the fourth times x to the fourth, and then let's do a little bit of simplification there. I'm going to open up Desmos. Should be 625. But just to demonstrate to you, and sometimes my brain hurts and I mess up math like that. So I'm going to do 5 on my real keyboard. You press Shift 6, and I can do 5 to the fourth, and I do get 625. Just a reminder: if you don't have if you don't want to use a real keyboard, you can press this A to the B right here to be able to get up into the exponent. So this will end up being 1 times 625 is 625, x to the fourth. All right, then plus, we still have our 4. This is going to be times 5 cubed, helps if I write a cube, times x cubed, and then we still have this 2 to the first, which is going to be a times 2. I'm going to go ahead and then take an extra line, and let's simplify this. Let's kind of reorder this together so it's clear that I have a 4 times 5 cubed let's go ahead and find what 5 cubed is. 5 cubed should be 125. So 5 cubed is 125. So I'm just rewriting this as 125 and then moving the 2 up front. I know I'm kind of it's probably maybe not advised to be working 2 lines at once, but since my brain is already on this and I know what I'm doing, and I know I'm familiar with this part, I'm going to go ahead and finish this up. So I'm going to do 4 times 125 times 2, and I get 1,000 x cubed. All right, let's keep going. So we still have our 6. Now we're going to end up with a 5 squared. Let's put a times dot, 5 squared, times x squared, and then we still have our 2 squared, which is 4. Let's rearrange this. So we have our 6 times 5 squared is 25 times the 4 times x squared. We grab a calculator and let's do that. So 6 times 25 times 4, and I get 600, and then x squared. All right, then let's do the next one. So we have our 4. Want to distribute the 5, distribute the 1 that's not really needed. Actually, let me just get rid of that because it's x to the first, so that's nothing really going on. We're just going to it's called the associative property. 4 times 5 times x times 8 we can rearrange. So this is going to be times 5 times x, and then this 2 to the third is a times 8. Let's take a second and rearrange this to be 4 times 5 times 8 times x. This line here that I'm writing is kind of optional. You should be able to see 4 times 5 times 8 and write that out front, but I just find it helpful to maybe see it like this, nice and clear. So 4 times 5 is 20. 20 times 8 is 160. We have 160x. And then lastly, we just have plus 2 to the 4th. 2 to the 4th is 16. So we end up with 16 here. I guess I should color that in the purple. Let me carry my 16 down. And there we have it. Let me double check it with the answer on the board. Make sure I didn't make an oopsie. 625x to the 4th plus 1000x cubed plus 600x squared plus 160x plus 16. So there's a lot going on there. One thing you could do, one note, it's a little bit more algebraic, but one thing that you can do on Desmos, if this was like on a quiz or test, you're like, ooh, I want to make sure I did this right, you could, on 2 different lines here, this is a little bit more algebra in a contemporary class. This is geared towards my contemporary class, but other people out there on YouTube, if you're seeing this and you're in an algebra class and you have access to a grapher, one thing you could do to double check that you did this right is graph them both. So here in Desmos, I've expanded this so I can see the graph over here. I'm going to type in, you don't need a y equals, but it just sometimes it's helpful to reinforce that you're graphing. Y equals 5x plus 2, close that with the parentheses, and then raise it to the 4th power. And so we get this crazy looking thing. It looks like a skinny parabola. It could kind of wiggle somewhere else, but it's looking like it's not, right? It's actually, I know it's not because this is a quadruple root right here. So then we have a y equals, and now I'm going to type in this whole thing right here. So we have 625 x to the 4th plus 1000 x cubed plus 600 x squared plus 160x plus 16. And if you notice, these two things are stacked, they look like they're stacked directly on top of each other, meaning they are the same graph, the same function. So since they're the same, that means that they do equal each other. So if you ever have an equation and you're trying to see if they equal, if you do something, not an equation, if you've done something to an expression, and you would see they equal, graph what you started with, graph what you ended with. If they're on top of each other, then that means you did it right. or at least you haven't made any noticeable significant errors. All right, so hopefully that helps seeing this application of the Pascal's triangle, how you can use that entire row to do a binomial expansion. To my students in my contemporary class, I think these are only two that use this, but this does show up on the quiz. One of those do show up on the quiz, so do make sure that we're familiar with them, practice them. If you did it and you want to do it again, press similar question to make sure that you're good to go, or ask me for help. I'll take you through this kind of similar process. The main thing with this, let me pop open my stuff. The main thing with this is take your time through this. So you saw how I have my binomial coefficients. I carefully wrote out I started with the first one and had it descend from left to right. So 4, 3, 2, 1, nothing. And then for the 2, for the one on the right, you could start with a 0 and work your way up. I like to start with the big, just start with the 4 that's supposed to be and work my way left. 4, 3, 2, 1, 0. Then put in the coefficients. 1, 4, 6, 4, 1. I haven't said it this time, but often when I'm doing formulas or processes like this, I will say, don't be a math hero. Students a lot of times try to start simplifying this right away. Nuh-uh. Just get this process on your page. We're not doing any math. We're just doing the work. We're just doing the process. Just write it out. Now that you have this, if you kind of want to be a math hero and be able to, in your head or with the calculator on the side, be able to quickly get to 625, be my guest. But this needs to be done on your scratch work so that way you can clearly see what you just did. Then take your time simplifying. This, like this particular one, we have a 4, we have a 5 cubed, we have a times 2. All those get multiplied and we end up at 1,000. So take your time going through these problems, and then I just showed you how you can check your work to feel good about it. All right, I hoped this helped. I know this is a lot more mathy than you're probably used to, but I hope this helped, and I'll see you in the next one. Bye.